Hi everyone, this video is the introduction of Unit 4 for Survey of Math, which will deal with all things linear functions. This video in particular will work through and review how to find domains, ranges, how to identify what is a linear function and what isn't, and how to write some basic rules and equations of linear functions. If you want to write down your own notes as you're watching this video, you can find the PDF of this note packet on Schoology in the Unit 4 folder in the Survey of Math class. You can also feel free to just watch the video and refer back to it as you need to. At the end of the video, I will post the IXL topics that will go with this particular section. So, like I said, this is going to review domain, range, basics of identifying functions, and writing rules. Let's take a look at the basics of domains and ranges. As you may recall, domains refer to the input of a function, which are typically the x values. The outputs, aka the y values, are referred to as the range values. So in short, domain is your x, range is your y. There are several ways that you can get these values depending on how you are presented the information for domain and range. So you can see the three examples I have here to start off. The first example, we have ordered pairs, and as you know, ordered pairs are written in XY order. So to list my domain and range, my domain is simply the x values. So all I'm going to do is pull out the x values from each of my ordered pairs and list them. You can list them in numeric order. You don't have to. That really doesn't matter. The range, again, I'm just going to list all of my y values. So I have 5, 0, -4. I have another 0 that pops up. Whenever you have a repeating domain or range value, you do not have to write it again, so I'm not going to. And that would be my domain and range. So one way you can pull it is simply from a list of ordered pairs. The second way you can pull it from is from a typical XY input-output table. Again, your input is your x, your output is your y. If your input is x, that means all the values in the x column would be your domain. So your domain would be the 0, 1, 2, 3, 4. Your range would be the y column. So again, we have some repeating values there. I'm only going to pull out the 9, the 8, and the 5. I do not need to write the other 8 and the other 9 again. The other way that you can pull domain and range is if I give you a graph. Now this here just has several points plotted, so what would make it easier is to list the ordered pairs first, and then it'll make it a lot easier to pull off those numbers. So, looks like the ordered pairs that I have -2, -2, -1, 5, 0, 3, 1, -1, 3, 8, and 5, -4. So I pull off all those ordered pairs, and that makes it a lot easier to list my domain and range. So again, I'm going to list for my domain all of my x values, -2, -1, 0, 1, 3, 5. For my range, I'm going to list all my y values. So -2, 5, 3, -1, 8, and -4. So that's how we can identify domains and ranges. Domain is your x, range is your y. Fourth question underneath here, your standard multiple choice. The function y equals x plus 7 has a domain of 0, 1, 2, 3. Which of the following is the range of the function? Well, if I give you a specific domain, all you have to do is plug in those numbers for x. So I'm just going to make a quick little xy chart. My domain is 0, 1, 2, 3. Plug that in for x. 0 plus 7 is 7. 1 plus 7 is 8. 2 plus 7 is 9. And 3 plus 7 is 10. My range is all my y values. 7, 8, 9, 10, which would be C. Now, one of the other things that you'll go through and review in this chapter is the basics of graphing, which again, whether you're Algebra 2 or Geometry, you've seen this at some point already this year. But just as a quick review, the most basic way you can graph is if you have a table of values. So here I give you y equals 2x minus 3. I give you a domain. If I give you a specific domain, those are the only numbers you need to plug in. So just plugging those in and doing some quick PEMDAS here. You can see I'm just, again, plugging the numbers in and filling out my chart. Since I'm only giving you specific numbers, these are the only points I'm going to plot. I'm actually not going to connect the dots here. I'm just going to plot those 5 points since I'm giving a specific domain. If I didn't give a specific domain, that's when you connect the dots and you can assume that makes a straight line going on infinitely. Same thing here in the other example. So I'll give you some nice numbers here so these don't turn into fractions as answers. But again, if I give you specific domain, all you got to do is plug them in. Those are your y values. So we go ahead and plot our points. And again, since I'm giving specific domain values, I'm not going to connect them. I'm just leaving the points as is. So again, quick review there on just how to plot some basic points, how to graph using a table. Now, we're going to take a look at next here, how to identify whether something is a function or not. Here is the general gist. So you can see the definition at the top. Function's a relationship between two variables in which every input has only one output. Here's the long and short of it. As long as all of your x's are different, you have a function. If your x's are not different, anything repeats in your x values in your domain, it's not a function. So if I look at number 1, I've got my xy table, my input-output. All my x values are different. Even though there's some repeating y values, that doesn't matter. In order to determine if something's a function, all the x's have to be different. So number 1, we would say yes, it's a function, because all the x values are different. But in the second example, we can see that I have repeating x values. I see the 0 pop up twice in the x column. So we'd say, no, it's not a function, because we have repeating x values. So whenever you're given a list of ordered pairs, whether it's in the normal formatting with the parentheses, it's in a table, whatever the case may be, if you have repeating x's, it cannot be a function. If all the x's are different, then you're good to go. So you see the question underneath here, you've got a set of ordered pairs, 1, 5, 2, 6, 3, 7, 4, 8. It's asking which ordered pair could be included so the set remains a function of x. So we see the x values 1, 2, 3, 4. So I need to make sure I pick an ordered pair that has a different x value. Only one that does is C. A, B, and D each have an x value that's already been used. C does not. Therefore, I could add that to that relation, and it would still be a function. We can also determine functions graphically by using the vertical line test. So basically, that's where you take a vertical line, drag it all the way across your graph. As long as it only crosses your graph one time the whole way through, you're in good shape. If you have a vertical line that crosses the graph twice at the same time, then it's not a function. So if I look at 4 here where I have all these random dots, if I were to take a vertical line and drag it across, I run into a problem in a couple of spots. That's not the best line here. Let's draw something a little bit nicer. So right there, it crosses twice. And right there, it crosses twice. That is a problem. So this is not a function. Now, it only has to have that issue once. It doesn't have to be multiple times. As long as if it crosses through the graph twice at the same time, it's not a function. Number 5, here's a parabola. I could drag a vertical line across it. It's never going to cross that parabola more than one time. So we would say, yes, it's a function. 6 is a sideways parabola. Well, as soon as we get to 0 and start going across, we run into issues all over the place. And I know those aren't the most vertical lines here. Make them a little bit nicer. But again, I could draw an infinite amount of lines here on the right side of the graph, and I'd have an issue. So that is not a function based on the vertical line test. So those are the different ways you can identify if something is a function or not. Tables, list of ordered pairs, graphically, etc. 7 and 8 are pretty redundant without the graph here, but it's just emphasizing, is this a function or not? So I give you a function with a specific domain. So again, if I give you a domain, that means I've given you x. Let's go ahead and find the range with y. So -3 plus 7 will be 4. -1 plus 7 is 6. 2 plus 7 is 9. 6 plus 7, 13. So it's asking the question just based on the domain and range, does this represent a function? Absolutely. All my x values are different. Therefore, we are going to assume based on this information that this is indeed a function. Number 8, same idea. So the domain of y equals x squared by x values given to me are -5, -2, 1, and 5. If I fill those in, so -5 squared is +25, -2 squared is 4, 1 squared is 1, and 5 squared is 25. So again, based on the domain and range, is it a function? Absolutely. Again, all my x values are different. Yes, I have a repeating range value. That's not a big deal. As long as my domains are different, we are going to say that this is indeed a function. So the last little bit of this here is the introduction and the review of how to write a rule. A rule is just another word of writing an equation. So in one of the other units that we have left in the year, we'll go back over some more formal ways that we'll write equations and write rules using point slope and slope intercept form and all that different stuff. But here, we're just going to look for some really basic patterns in our tables. So 9, 10, and 11 here, I give you a table of values. Really all I want you to do is figure out what is the pattern. What's turning the domain into the range. So we're just going to look for some really basic patterns here. So if I look at number 9, I can see my domains, I see my ranges. So what you want to do here, if we're just looking for basic patterns, well, what's happening in the first ordered pair? How am I getting from x to y in the first column? Well, they get from 0 to 3, logically speaking, but the only thing I can think of is we're adding 3. Same thing in the next column. How do I get from 1 to 4? Add 3. 2 to 5, add 3. 3 to 6, add 3. We can write a rule saying to get y, we are taking the x value and adding 3 each time. That's your rule. If I look at the next table here in number 10, same deal. How can I get from x to y in each column each time? So I see 2 logical options for the first column here to get from 3 to -6. You can multiply by -2 or subtract 9. Both would be logical options. But remember, you are looking for the same pattern in each column to figure out what the rule would be. So if I look at the second column from 4 to -8, multiplying by -2 works, but subtracting 9 doesn't. So we're going to go with multiplying by -2 and see if that checks out with the rest of them. 5 times -2 gets me -10. 6 times -2 gets me -12. That seems to work out pretty nice. So to get y, I'm taking the x value and multiplying by -2. So my rule would be y equals -2 times x. And last but not least, look at the table underneath here. Same deal. Look at the first column. I see 2 logical options. To get from x to y, dividing by 4 or adding 12. If I look at the second column, I can definitely divide from x to y. To get from x to y, I can definitely divide by 4, but adding 12 would not work. The third column, divide by 4 works. Fourth column, dividing by 4 works. My rule would be option A, y equals x over 4. So again, this is your basic introduction. And again, this is all stuff that you've learned at some point, some of you maybe multiple times over, but just a quick review there of domains, ranges, identifying functions, and writing some basic rules. So, just like regular class, again, one of the nice things about survey is that what we're doing is really not any different than what you've been doing in class. The only difference is you're not sitting at a desk in school. So, what you are going to do for all of these lessons is no different than what you were doing in class for me. You're going to work through IXL just like you normally would. So, your IXL, for this chapter, everything fits in level K, so make sure on your IXL app you are on level K. Now, most of these I'm going to try to keep to 1 topic, maybe 2 at the most. This is one of the few instances where I'm giving 3 only because with what you just learned, it's a lot of yes or no questions. They are very quick to answer. At least they should be anyway. So, the 3 topics I'm going to give you in level K are going to be Q2, Q5, and Q6. Just like always, your target score is 80. If you get to an 80 or above, you'll get 8 out of 8. If you're one of the handful that possibly you might have started some of this last year or the year before in Algebra 1A or 1B or whatever the case may be, again, you do have to do some of it in order to get the score to appear on the grid. So please make sure if you look at it and it says, oh, I have like a 70 already. That's great. That means you have a little less to do. You need to still do the rest of it in order to get a score to trigger in my grade book. So, as always, if you have any questions, no different from class, if you have any questions on things, please get a hold of me. If you're getting stuck on the same type of problems over and over again, please contact me so I can help you work through it so you're not stuck in the mud on this. Your grades are going to be solely the IXLs, so please make sure that you are keeping up with these and doing them. I'm going to make sure these due dates, these are due on a weekly basis, as you'll see in the calendar that I'll post on Schoology. So please make sure that you're keeping up with them. We're not going to wait 3 weeks and then do them all at the last minute. So please make sure, again, you're working on these as they're getting assigned. And if you have questions on things, you're getting stuck, please get a hold of me. Thanks for watching, and we'll see you next time.